Dear viewers, welcome to our lesson today in chemistry. I am your teacher, Mr. Steve Gitau. I'll be taking you through a revision topic in Organic Chemistry 1. This is a series of lessons that we have been having on remote learning. I do welcome you, and this is suitable for Form 4 candidates who are revising for the Kcse, and is also suitable for Form 3s who are looking into this topic. How are we going to do it? We are going to have a 30 minutes recorded lesson whereby I will take you through reactions on alkanes, and then I will give you an activity which you will report in 10 minutes out of the 40 minutes of this lesson. So welcome, and we are going to do this in form of a flow chart whereby we are going to look at various steps and the reactions that alkenes, that is ethene, which is our representative of the alkenes, will be undertaking with various other reagents. Welcome, and let's get moving. We have this flow diagram which shows at the center ethene, and on the sides we have ethene, and ethene gets us the product ethane. So for us, through a series of questions, we shall ask ourselves, what is the name of the process that leads to that part? What are the reagents that are used to get that reaction through? And possibly, what is the reaction? How does the reaction go for a particular area? Now, in step number 1, we are seeing ethene become ethene. What has happened there? In a simple way, we see that the 2 carbons are maintained, the 2 hydrogens become 4. So that's a very simple hint to the learners on what happened. Hydrogen was added. We add hydrogen to ethene to make ethene. So the process here is hydrogenation. Hydrogenation, and this one occurs in the presence of a catalyst, nickel catalyst, at a temperature of approximately 180 degrees or 200 degrees. So when we get to ethene, the same process, at the addition of hydrogen through the process called hydrogenation, you find that the 2 carbons are maintained, so that is the family of the eth. Then we have 4 hydrogens become 6. Hydrogen was added, and that means we needed the catalyst nickel and a temperature of about 100 degrees centigrade. So we are saying the reagent here is hydrogen gas. With the reagent here is hydrogen gas. That is hydrogenation. In the activity that we are going to have, I'll give you some sample questions on you writing the equation. For instance, now we move to our section on writing, and I would like you to write the equation. Number 1, write the equation for the formation of ethene from ethene. So this is our activities board, and activity number 1 is you write that equation, and during the live section you will report on that one. Let's move on to step number 3. In step number 3, we can take one of the reactions whereby chlorine gas is added. We add chlorine gas to ethene. So what is the name of that process? That process is called halogenation in general, that is halogenation. But if you want to be specific, then we call this one chlorination. Chlorination. And I would like to ask to go through the question on ethene undergoing chlorination. So I would like us to use the open structure kind of a molecular formula, open structure formula instead of using the molecular formula, and we see how is chlorine added across the double bond. So you find that the chlorine molecule actually comes as a covalent bond between two chlorine atoms, and when this bond breaks, together with the double bond breaking, we get that the hydrogens that were there are still present. The breaking of this double bond creates a hydrogen, an electron at this point, another one at that point, and the chlorine atoms attach there, such that we have a complete covalent bond between the carbon and the chlorine. This is the kind of reaction which we call addition reaction. This is an addition reaction of chlorine, that is this chlorine, across the double bond. And what is the name of this compound? Therefore, this compound will be 1,2 dichloroethane. 1,2 dichloroethane. That is halogenation, addition of chlorine across the double bond in alkane. Specifically in our question here we are using ethene, so it becomes 1,2 dichloroethane. Let us move on to step number 4. We see what would happen if we have HCl being added across the double bond in ethene. Now, HCl, hydrogen chloride, is a type of hydrogen halide. A compound of hydrogen and a halogen, we call it a hydrogen halide. Now, hence, that process is going to be referred to as hydrohalogenation. Hydrohalogenation. Hydrohalogenation is the addition of a hydrogen halide across a double bond, maybe in an alkene. So how is that reaction going to be? We have, let me use black, we have the ethene, and to it we react it with HCl. And what is formed? Sorry. You find that when hydrogen chloride bond breaks, we form the two atoms, hydrogen and chlorine, and they will attach themselves to the broken double bond, whereby one bond will be left. That is to say, the carbon to carbon will be left with one bond, the hydrogens will be there, the 4 of them as they were originally, and this bond will break. One electron will come here, one will come here. The hydrogen will come with its electron, attach itself here. The chlorine will come with one electron and complete that bond and attach itself there. And so this compound will be called chloroethane. Chloroethane. And that will show the distinction between when hydrogen chloride is added across the ethene double bond and when chlorine is added. You can see the products formed are different. Let us move on to another reaction whereby we form or we react it with hypobromous acid, HOBr. Viewers, I would like us to first of all to understand how this compound is formed. You find that when bromine gas is dissolved in water, it forms two products, that is HBr, hydrogen bromide, and hypobromous acid. So this one already we have had its representation at this point. The sister product, hydrogen chloride, representing hydrogen bromide. So even if hydrogen bromide was placed here, the reaction would be the same, forming bromoethane. However, we ask ourselves, what if this one now were to be the one to react with ethene? What would happen? What would be that kind of a reaction? So we get it that since this bromine is being dissolved in water, we normally say that this reaction with hypobromous acid, HOBr, is a type of halogenation. The HOBr represents a halogenation type of a reaction. So we say in step number 5, this is halogenation. Halogenation. It's only that the bromine is dissolved in water. So how does it go? Let us see. Ethene, we put it in that form. We have ethene there. Ethene reacting with the HOBr, hypobromous acid. What is formed? As we had discussed in the earlier steps, you find that the bond of the hypobromous acid breaks between the OH and the bromine atom. And once more, one of the bonds in the double bond will break. So generates the carbon-to-carbon single bond. Then the 4 hydrogens that were previously there are present. When the double bond breaks, these two electrons, each will be left at the carbon, and then these two will move. The OH will move as a radical and will attach itself on one of the carbon atoms. Let's take this one, and then the bromine being heavier, has a higher atomic mass, will move second after the OH with atomic mass of 1 plus 16, 17, or this is about 53 atomic mass. So we have the bromine attach itself at that point. However, this is a very important reaction in the sense that, unlike the way we named the earlier cases, the naming here takes a different specification. In this sense, the fact that OH is in this compound makes that the OH is a functional group. What is a functional group? A functional group is an atom or a group of atoms which, when they are in a particular compound, they give it some characteristic properties. When OH is in a hydrocarbon, that compound becomes an alcohol. In chemistry, we call them alkanes. So this immediately, the moment the OH is attached to a carbon atom, becomes an alkanol. Now, the second most important concept to know is that when a functional group is in a compound, that functional group takes priority. The carbon atom it is attached to becomes carbon number 1. So this will be our carbon number 1, while bromine takes carbon number 2. So we are saying the fact that the OH is attached to our carbon atoms that form this bond, the OH is on carbon number 1, while the bromine is on carbon number 2. So hence, what is the name of this compound? We shall call this compound, we start with the halogen, which is a substituent on carbon number 2, so 2-bromo, and the parent is an eth in the group of compounds we call alkanes, so it becomes 2-bromoethanol. And maybe we can also say 2-bromoethanol. But since we have only 2, then this will be enough to call this 2-bromoethanol. Now, the 2 is, as I had said earlier, signifying the position of bromine is on carbon number 2 and not on carbon number 1. So it would be wrong for us to call this bromoethanol, because the bromine is not on carbon number 1. It is the OH which is on carbon number 1. So viewers, let us take note of that specification in the change of the name. Let's move on to other reactions which we have not possibly discussed. And here we are going to discuss on the reaction of ethene with some oxidizing agents. So this is basically going to be a kind of oxidation kind of a reaction. Using what? Oxidation using acidified potassium manganate, solution, which we show as H plus for the acidification and potassium manganate. So how does ethene react with acidified potassium manganate in an oxidation reaction? So we can get this best through the reaction. And how is the reaction? We shall get it that ethene, we take that, that is the molecule for ethene, and we are going to react this with acidified potassium manganate. The H plus signifies acidification, presence of hydrogen ions in our oxidizing agent, potassium manganate, and this one takes place in a two-step kind of a reaction. First, the double bond breaks so that we have the carbons, the double bond breaks, then we have the hydrogens that were originally there, we have that. When the double bond breaks, one electron comes here and the other one comes here, so we shall not have that double bond. So that is the nature of our step 1. Then oxygen from this oxidizing agent being carried by the hydrogen ions, which is acting as a catalyst, speeding up the reaction. The oxygen is attached at this point. We have the oxygen, and immediately hydrogen attaches itself there, such that we eventually say that we have the OH. So just like in the previous case, the OH is a functional group, and therefore this is a double alkano. We call it a triol. So in the naming, we shall say, what is the parent? The parent alkane is an eth. So we shall have ethane, that is ethane 1, 2 diol. Ethane 1, 2 diol. What does this one mean? That the parent is an 2-carbon chain, has two carbons in its longest chain, and on carbon number 1 and on carbon number 2 we have the functional group OH, which is in the alkano series, and that's why we say di, 2 of them. In carbon number 1, carbon number 2, we have an OH attached to the carbon, so the name is ethane 1, 2 diol. The potassium manganate is the oxidizing agent. Hydrogen serves as the catalyst, which speeds up that reaction, carrying the oxygen to this kind of a bond. And that one we say is oxidation. Let us move on to reaction number 6. And in this one, we shall see a very common reaction, which is also very useful in our life because it produces very many products. That reaction, we call it polymerization. So in step number 6, we have polymerization. So I would like us to look at how does polymerization occur. How does polymerization occur? You find that in polymerization, we have a monomer of ethene reacting with another monomer of ethene, usually under pressure and heat, to form a continuous chain or a large chain of the monomers which are joined together, which we call the polymer. So in this case, we can visualize it as we have ethene molecule. We have an ethene molecule. We have an ethene molecule combined to another ethene molecule. And this, after the bonds break, you find that this bond will break, the electron will shift here, such that we get the 4 carbons now linked up. This bond, when it breaks, the electron comes over here and another one comes here. When this bond breaks, an electron comes here and another one moves here. Alternatively, we can visualize it that the electron will push this hydrogen up here, so that you have it here, and that electron will come over here. So we have this electron, the bond, once it breaks, that electron coming here and the other one coming here, such that we have the hydrogens like that, like that, like that. Now, when these 2 electrons join up and this is alone, we can have this hydrogen here, and that way we have this electron on the terminal carbon in that form. We find that we express this carbon, this electron, as a half bond like that. We express this electron as a half bond like that, and that way we are able to show in a very simple way the polymerization of ethene. 2 monomers of ethene, that is, this is an ethene monomer, and this is the ethene polymer. This is the polymer, which we call we call it polyethene. I'd like you to be cautious about the name. Amidst the fact that there are no double bonds, we do not call it polyethene. We say polyethene, suggesting the source of the polymer and how we got from the monomer ethene joining up and so on. There is another method of showing this, and that we are able to have that. Viewers, I would like us to move to the activity section, whereby you will be able to construct such a similar flowchart now using another alkene, let us say propene. We use propene to construct such. And when we construct that, we shall be constructing our own knowledge, and it will be very good. However, I will guide you through the construction. In activity number 2, we shall write down the reaction. Write down the reaction of propene with a chlorine, with chlorine gas, B with hydrogen chloride gas, and C with hydrogen bromide. We shall also write it down, its reaction with acidified potassium manganate as an oxidizing agent. And E, we shall also write it down in terms of how does it react with that is the polymerization, polymerization of propene. How does it get polymerized? And in each case, we shall put a rider there. In each case, name the product. Name the product. Name the product. Viewers, I would like to join you in the live section. However, I'd like you to note that this material is recorded and we have it on YouTube. Please search for my educational YouTube channel at Steve Getao 3660, where you'll find more videos in chemistry and some in mathematics. Let me join you in the live section, and thank you for watching.